Hi everyone. Today we are going to study about machine learning activities and basic types of data in machine learning. Let us start with machine learning activities. There are four major activities that are associated with machine learning. First activity is which is starting with data. Here, input to machine learning can be a data which is labeled or it can be not labeled. In case of supervised learning, we want labeled data, that means those data whose output is already known to train the machine. And to train or to make unsupervised learning algorithm, we require non-labeled data. This data cannot be directly fed to the machine learning model. That's why we prepare data first. That means data review and exploration is needed before moving to machine learning activity. Depending upon the type of data and the quality of data, we need to carry out different pre-processing activities. Now, what are these pre-processing activity and how to carry out or how to handle different categories of data? That's why we need to first understand what are the different categories of data and how we measure the quality of data and how to handle different types of data. Here we are first going to discuss the process of machine learning. As indicated inside this diagram, you can see the input data is fed to the very first step, that is called as preparing to model. The second step is the learning phase. The output of preparing to model is data pre-processing, and the output of this input data is converted into refined data. Now this data is the input data is not ready to get consumed by machine learning models. We need to convert this data into machine acceptable form. That is nothing but we mean by refined data. The data is being converted and pure so that machine can understand it. And this refined data is given to the learning activity, which is the learning the insights which is covered by the refined data. Then later on we do performance evaluation, and after at the end we perform improvement to our model. Quickly look into detail each and every step. What do we do inside preparing to model step? We basically first understand the type of data which is given as in inputs data set. We try to explore this input data and try to understand its quality and nature. We also find the relationship among data elements. That means if my data contains 10 rows and 15 columns, what is the relationship between column 1 and column 2? What is the relationship between column 3 and column 5? And so on. That is nothing but the relationship among data elements, which is also called as inter-feature relationship. So we first try to find out type of, quality, nature and relationship of data. We also here intend to find out any potential issues in data. Say for example, some data elements are missing. Say for example, row number 3, column number 5, there is no data that is present. So that is an example of missing data. Or we can have outlier data. All these kind of data must get identified before the learning start. So here we identify all the possible issues in data. We do remediate the data. That means we do the purification of this data. If my values are missing, we are actually imputing missing values in remediation of data. And we also need to apply some pre-processing steps. Pre-processing steps might include dimensionality reduction. That means if my data contains hundreds of attributes, do I really need those 100 attributes in order to make learning model, or I do need only 5 to 10 attributes that will be enough for my model. So dimensionality reduction is basically finding the attribute set which is required for machine learning algorithm. And we also do feature subset selection here. That means do we need to create more attributes, or we need to combine the attributes and make a subset of attributes so that it will be enough for machine learning model. So this is these are the steps, these are the important points that are carried out during the very first step of machine learning, that is called as preparing to model. The next step of machine learning is learning itself. Here we select a model, we select the type of representation of model, and we try to fit data over this model. So here we do data partitioning or holdout. That means not complete data which is given input to the system is used for training machine learning. We here perform an important step that is called data holdout or data partitioning. We will look into detail data partitioning or holdout. Basically, we divide our data into two categories, training as well as test data. And this training and test data is being carried out or separated out basis or on the some basis. And that category, that number of features or parameters that must be considered while we are partitioning the data into learning set or test data and training data. After the data is being separated or it is being hold out, partitions are being created, we do model selection. What kind of model do we need to represent? Do we need to do supervised learning or do we need to do supervised learning? Within supervised learning, do we need to classify or do we need to perform regression? Within regression, do we need to have linear regression or non-linear? So all these things have to be considered. And according to these parameters, we choose a correct model. And that model is selected for implementation. At the end, we perform cross-validation parameters. That means we will first decide what will be on what basis we will justify our predictions. So whatever the output at the end made by machine learning algorithm will be justifiable, will be taken up to the marks. So those marks has to be carried out or has to be set at this stage. So that is nothing but we will set the rules of cross validation. We will set the rules to justify the output of machine learning algorithm. Third step is performance evaluation. In this activity, we examine the model's performance. That means we have some matrices, some measures to identify and to find out the model's performance, whether the model is predicting something correctly or not, whether it is classifying accurately or not. So all these things are measured. The performance of model is measured using some measurements, and those measurements are nothing but measure of performance. We have different performance measures for different types of model. Here we can do visualizing of performance. We can plot different graphs and different plots so that we can find out the working, the performance of model that we have just implemented. Last activity is performance improvement. In this particular stage, we are actually improving our model, we are changing our parameter, we are changing our bias so that the performance of model will be up to the mark. Say for example, currently my model is giving output with accuracy say 95%. But we are striving to achieve the model's performance accuracy up to say 98%. So we need to change some parameter inside the model. We do not need to change the model, but we do only need to change parameters within model. So we need to tune the model. I will adjust some parameters within the model. That is what I say, tuning the model. We do ensembling. Within an ensembling, we perform different data sets over different type of model in order to achieve single task. So ensembling can be also performed to find out different output of different model. We also do bagging. Within bagging, different data sets are applied and different set of training data are used to train the model, and we check the performance evaluation of each machine learning algorithm. So we will study step number. We also have process called as boosting, which is used to improve the performance of machine learning. So basically within step 4, which is improving the performance of model, we can use either of the technique to improve the performance. We can either tune the model, we can bag, we can boost, or we can ensemble the model to improve the performance. So here basically in unit number 2, we are actually looking into detail step 1, that is preparing to model. Step number 2, 3 and 4 are actually separate chapters and we will cover them later in detail. So let us start with basic data types in machine learning. Now, what are the data types in machine learning? A data set which is given as an input to machine learning algorithm is actually collection of information or records. Now remember, this collection of record is complete entity and it depends on some subject area. Now this raw data which is input to the machine learning system is called as raw data set, or simply in simple language they are called as records. Now say for example, the example that is shown is two tables. First table is student data set table and second table is student performance data set. So there are two data set and within that data set we have series of rows. Row is nothing but that red highlighted part in which we have information about one data set, the one data element. That means roll number 129-1013, whose name is Chanda Bose, was female type and age is 14. Their respective math score is 68 and science score is 29 and their overall percentage secured is 64.67. So these kind of information is represented in a tabular format, for example, is called as raw data. And the blue highlighted part of data is called as attribute set or the columns of data set. So in each data set, we might have multiple set of attributes and multiple set of records, which gives information about specific characteristics. Now, we were actually discussing types of data in machine learning. The data is represented in a form of rows and columns and each cell value is called as basic data. And that basic data or entry on particular cell is called as data set entry. And that value can be categorized according to this particular tree. The attribute value or a cell value can be either of type qualitative, that means categorical information, or it can be of type quantitative, that means numerical type information. Again, we can divide quantitative information or categorical data into two different parts called as nominal and ordinal. And we can also divide our quantitative, that means numerical information, into more two parts that are called as interval and ratio. Now, each of these category of data have their own set of characteristics, their own set of properties. Now, let us dig into the detail of these. First, we will look into qualitative data. Qualitative data is also called as categorical data. They provide information about the quality of an object or in information which cannot be measured. Say for example, name of a person is a categorical information or the branch of a student is again a categorical information. The performance of a kid in an examination, say poor, best, average, all these are called as qualitative data. They does not give a quantitative measure or they do not give us a numerical measure. That's why they are called as categorical or qualitative data. They cannot be measured using scale of measurement. The first type inside this is nominal data. Now this type of data is a categorical data, that means they do not have numerical equivalent to it and they are actually having named value, and this named value cannot be quantified. We cannot quantify these values. Say example, a blood group of a person. Whether it is A positive, B positive, B negative, AB negative, O positive, all these are nothing but type of blood group values which are possible to have. We cannot justify that AB negative is better than B positive or O negative is not better than O positive because we are not able to compare their values. That's why they are categorical as well as they are nominal because we cannot measure the two values or within the same relation or within the same attribute. Similarly, if nationality of a person, whether Indian or British or an American, you cannot measure them. Where I cannot say a particular person having one nationality is better than another person having another nationality. Similarly, gender, male, female, or other. We cannot measure or we cannot do greater than or less than comparison or equality between these values within an attribute. So here, nominal data is a type of categorical data where elements value cannot be measured, cannot be compared. There is one special case when an attribute can have only one of the two possible values. Say for example, result of a student. We can have either value pass or fail. These kind of attributes or these kind of data is called as dichotomous data. This is nominal, categorical, having only two possible values data is. Now, what operations we can perform on nominal data? Since we do not have quantifiable attribute, we do not have numerical value, obviously mathematical operations cannot be performed. As well as we cannot perform any statistical measurements over this data. The only measurement that we can do is counting the data. We can count the occurrences of particular value within a given data set, or we can find mode. That means we can find out the maximum time appearing data. Say for example, within a student data set, maximum time there are students which are of type male. So male I can say mode of given data set is male. So this is the example, or these are the two operations that are only permissible over the nominal data. Second type of categorical data is ordinal data. This data is also non-quantifiable. That means they are given in non-numeric form, but we can arrange these values in a sequence of an increasing or decreasing value. That means we are able to compare the value of between two given values. Say for example, customers satisfaction is very happy, happy or unhappy, or I can say sad. So I can give ratings based on this, that very happy is better than happy, happy is better than unhappy, and unhappy is better than sad. So I can arrange these series of values in some ascending or descending order. So different operation we can perform on the ordinal data is again counting, we can find mode, we can find median, and we can find quartiles. Now what do we mean by quartile and what is the procedure of quartile will be covered later in our lecture. What we cannot perform any addition, subtraction, that means any mathematical operation, or we cannot perform any statistical operation like mean. Second category of data is quantitative data or numerical type data. Here it gives an information about quantity of object in some numerical form which can be measured using scaled measurement. Here there are two types, interval and ratio. Let us look into interval data. Interval data is a numerical data for which order is known, as well as we can find out the exact difference between the two values. Say for example, when we were discussing ordinal data, we can have order between happy and very happy customer. But we cannot find an exact difference between very happy and happy customer. Well, in interval data, we have an ordered values. We can obviously find the relationship between two values in an ascending or descending order, but also we can also find the exact difference between these two values because these two values are numerical in terms of nature. Say for example, temperature in Celsius. If I say temperature is 12 degree and second temperature is 18 degree, the difference between this temperature is 6 degrees. Similarly, the difference between 15.5 centigrade of degrees and 21.5 centigrade degrees is also 6 degrees. Similarly, I can find out the difference between any two given dates or any two given time also. So this kind of data whose order can be found as well as the difference between these two, any two values can be found is called as an interval data. Now this interval data have one property which is not possessed by them, and that is called as true zero property. That means we can have positive as well as negative values for this particular attribute. Say for example, a temperature can be measured in negative degree centigrade. The type of operation that we can perform over this interval data is all mathematical operations like addition, subtraction, we can find mean, statistical operation like mean, median, mode and standard deviation. But the operation that cannot be performed on interval data is ratio. Now, second type of data is called as ratio data. Ratio data is also numeric type of data in which order is known, in which we can find an exact difference, but which do have an absolute zero value. Now, what do we mean by absolute zero or true zero value? We do not have any value which is lesser than zero. That means, take an example of height of a person. Height of a person or any object cannot be negative. Marks scored in exam. It cannot be negative unless and until we do not have negative markings in exam, of course. Salary of a person cannot be negative. Or age of a person cannot be negative. All these are an example of ratio data. They do have an order, they do have a property to calculate difference between two values, and they do not have any negative values for their attribute. So this is ratio data. We can perform all type of mathematical as well as all type of statistical operation over the ratio data. To summarize our type of data, one table has been created which gives scale of measurement in which we have four different types: nominal, ordinal, interval and ratio. Four characteristics. First one is labeled. That means do they have value? Yes, they all do have value. It can be either textual value or it can be a numerical value. Can we find numerical order between these two? So yes, we can find numerical order between ordinal data, interval data as well as ratio data. But the order between these values cannot be found out within nominal type of data. Say for example, blood group. Are we able to find out the exact difference between any two values? So yes, we can find out the exact difference between any two values under interval as well as ratio data only. We cannot have an exact difference between two values of nominal data and ordinal data. And fourth category or fourth characteristic is true zero value. That means do we have negative values? So we cannot have only negative values for ratio data. For all other type of data, we can have negative value. We can also categorize data into some different way. That means either attribute can have a discrete value or it can be a continuous valued attribute. Discrete valued attribute are those between any two numbers I cannot have a range of values. Say for example, roll number of a person. Roll number of student 1 is 1 and another student is having roll number 2. Between value roll number 1 and 2, I cannot have any person or any student which is having value roll number 1.2 or 1.8 or 1.1, so on. So these are called as discrete valued attributes. Another category of attribute is continuous valued attribute. That means we can have set of real numbers to that attribute. For example, length of an object. Length of an object of say object 1 is 10 centimeter and length of another object is 11 centimeter. I can have any number of objects might have an attribute value like length 10.1 centimeter, 10.12 centimeter, 10.168 centimeter, 10.9909 centimeter and so on. So an attribute having numerical value is called continuous valued attribute. An attribute is having discrete value is called as discrete valued attribute. So in today's lecture we have seen machine learning activities and with basic types of data in machine learning. We have seen different categories and the characteristics possessed by each of them. Thank you everyone for watching this video. This is Munira Topia signing out.